We have talked about polynomial functions, what they are, and a bunch of their properties. And like I said, the goal of this unit, like the previous unit with radical functions, is we get to the point where you're given a polynomial function and you can graph it, or you're given the graph of a polynomial function and you can make the equation for it. Okay? In order to graph them and eventually find the equation, these polynomial functions have to be in factored form. So we have to be able to factor. You guys know how to factor x squared trinomials. You know how to factor difference of squares. You know how to do GCF, but we really haven't seen ones like this to factor. Okay? So we're going to have to know how to divide these things by factors that we find. But before we do that, we just need to learn how to divide. Yesterday, I talked about an example where we used long division, and it looked very complicated because of all the x's and the exponents and the numbers. So like I said, we're not going to worry about this. Okay? We're going to divide them using something called synthetic division. So to use synthetic division, I have to take the coefficients and the constant of the polynomial I'm dividing into and just write the coefficients. Okay, so looking at what we're dividing into, starting with the highest exponent, what's this coefficient? 2. What's the next one?
1.
And the next one? Careful. -1. And the last one? 3. I'm not going to use the x squareds and x to the x cubes and x's as part of it. I'm just going to focus on the numbers. Okay? So it's these I'm going to actually divide. And since I am dividing by this, so whenever we have a polynomial divided by a binomial in subtraction form, okay, what I'm going to take all these and divide by this number here, a. What is this number a? Remember, this has to be in subtraction form. It's -2, because it's the same as x minus -2. So what I'm going to do, okay, is we're going to divide these. And actually, I didn't need to be so far away, but that's okay. So here's how we do it. We follow this process. And really, it's just the process of long division. I'm not going to get into a detailed explanation. First of all, leave a space to write some numbers. And then we're going to write some more numbers here. First number, we just dropped down. Okay. Then, multiply and put the answer in the next column. So -2 times 2 is -4. Add instead of subtracting, because we're actually using the reverse sign here, the opposite sign here, which is why we changed subtracting to add. 1 plus -4. Start the process again. Multiply and put it in here. So -2 times -3, 6. Add. Five. One more time. You can see it's kind of similar to long division, but it's not as complex looking. That answer goes here, so -2 times 5, -10, add gives us -7. These are the coefficients along with the remainder of the answer. If the highest degree in our number that we are dividing into is 3, then I start my answer with 1 less. So to write my answer, okay, I'll write it over here. Because remember, when we divide these, we're going to get an answer that had like x's in it, some exponents. So 2, 1 less than the highest exponent, 2x squared. And then work your way down. Minus 3, 1 less, x to the first, or just plain old x. And then here is your constant, plus 5. And here's your remainder. And how do we write the remainder? We write the remainder over what we divided by, like so. And that's our answer. Remember, this is the first run through. You'll get it. So we use the coefficients, we do a series of multiplying and adding, and then we write our answer starting with the next lowest exponent. One other thing you need to keep in mind. The exponents have to be in order from highest down to lowest, and we have to account for every exponent. So what's the highest exponent in this one? So it's really 4x to the third. What about x squared? Is there an x squared? So how can I add an x squared? What would I put in front of it so that it really represents nothing? That represents nothing? 0. And then the x term, which is 9, and then the constant. And remember, since we're dividing by x plus 2, once again, a is going to be -2. So here's everything we need. So we've got -2, and then 4, 0, 9, -12. Drop the first one, and then it's a series of multiplying and adding. It goes here. -8. Because we multiply those two and now add. -8. Multiply and add. Multiply and add. Right. There are the coefficients of your answer along with the remainder. So how would I write my final answer? It would be, starting with this one, 4x, 1 less than the highest, minus x plus 25, and then minus the remainder over what we divided by. That's all that up at the top where it says this. I know you look at this, you'll see this in the instruction, and it might get you confused. Okay? We did this using synthetic division, then you wrote your answer and the remainder over what you divided by. That's all that means. Okay? Okay. Again, we're going to ignore this. There is a valid reason for knowing what the remainder is in synthetic division when we actually start factoring these things. Because when we factor, remember, a factor of a number is something that goes exactly into it. Like 2 is a factor of 12. Why? because 12 divided 2 is exactly 6 with no remainder. Right? 7 is a factor of 28 because 28 divided 7 is exactly 4 with no remainder. So when we define factors, we want no remainders. So finding remainders of 0 is important. So there's two ways we could do this. One is synthetic division. Okay, like here, look at the question. We're not asked to write the answer full out. We're just asked to find the remainder. So if I use synthetic division, what's my number here? 3. What are my numbers here? 2, -4, 3, -6. See if you can go on this one. Remember, drop the first one, multiply, add, multiply, add, multiply, add. So I'll drop the 2 down. Whoa. I would drop the 2 down. 3 times 2 is 6. Add. 3 times 2 is 6 again. Add. 3 times 9 is 27. Add. And this is what I want to know. So R, the remainder, is 21. I don't have to write the full answer on it. There is a quicker way we can find the remainder without doing synthetic division. Take this value of A, and plug it in for X. So I'm going to find P of 3. I'm going to plug 3 every time I see an X. So I get 2 times 3 cubed minus 4 times 3 squared plus 3 times 3 minus 6. And then I'm going to calculate that. So this gives me 2 times 27 minus 4 times 9 plus 9 minus 6. 2 times 27 is 54. 4 times 9 is 36 plus 9 minus 6. And 54 minus 36 is 18. Plus 9 is 27. 27 minus 6 is? No. No. Jesus Gasio. That is unbelievable. Like, mathematics is beautiful. I love when that stuff works out like that. That's insane. So there's a quick way. Probably shouldn't have said that on video, but anyway. No, sorry, I was distracted there for a second. There's a quick way to find the remainder. Take the value of A, plug it into the, all right, are you okay? Stop it. You should make it be loud. Okay. Plug it in for X to the function, you can calculate the remainder. Or, I mean, you could use synthetic division. So, here's where synthetic division is not very helpful, where the remainder theorem is good. What's the value of A first? 1. Don't write this down, but if you had to use synthetic division, what's the highest exponent you see? And then what number's in front of it? And now we have to account for X to the 9, which is 0, then X to the 8, 7, 6, 5, 4, third, second, finally, minus 15, then 18. You can see that's a little cumbersome. Okay? This is where the remainder theorem is handy. I said, don't write this down. So let's just take 1 and plug it in for x. And then just calculate that to get the remainder. I don't have to do that synthetic division. So 1 to the 10, 1 minus 15 plus 18 gives me a final remainder of 4. So if I would have used that long synthetic division with all the zeros, I would have got 4 at the end. Okay? Believe me, this will be helpful when we look at the next step in factoring these things. Okay? A little bit of a challenge question to finish up. You're given a polynomial, you're told what it's divided by, but this time you're told the remainder. So when we take this thing that has a k in it, it's missing a coefficient, and divide it by x plus 2, we get a remainder of 1. Any way on how you can figure this out? To find the remainder, what would I plug in for x? Negative 2, right? This a is negative 2. So if I plug in, I get k times negative 2 cubed plus negative 2 squared plus 2 times negative 2 minus 7. That's going to give me the remainder, right? Well, we're told what it is. It's going to equal the remainder of 1. What did we just create? An equation that we can solve for k. I know, it's crazy. Negative 2 cubed is negative 8 times k is negative 8k. Plus 4 minus 4. Those are going to cancel each other out. Minus 7 equals 1. Plus 7, add 7 to both sides. Negative 8k is equal to 8. Therefore, k is negative 1. So that time, we're still using the remainder theorem, but we're told what the remainder is. We're not calculating it. And we're told what it is, which allows us to find one of the missing coefficients. Okay? So that's the next step, is figuring out, okay, how do I get remainders? Because when I actually start to factor these things and I start dividing them, I want no remainders. So I want a quick way to find a remainder of 0. And that's what this remainder theorem does. Okay? Okay.